So hello everyone. So today we are going to discuss about uh, introduction to machine learning. So this module will discuss some basic concepts of machine learning and the different types of machine learning. And if you have any questions or comments, please drop below this video. Okay, let's get started. So in this module, we are going to discuss about the fundamentals of machine learning like supervised, unsupervised, reinforced models, basics of machine learning, right? And the other things as well, right? So first, why do we need machine learning, right? So machine learning, what is the difference between the traditional computer programming and machine learning programming, right? So if you look at the digital platform, millions, trillions of data are being generated every day, right? So uh, to process all those huge amounts of data uh, through normal or traditional computer programming is not at all possible, right? So machine learning will help us to process all these huge amounts of data so that we'll get insight to the data, right? So as you aware that data is the fuel for the current generation computing devices, right? And the computing power generated by the latest technologies, right? Processors is outstanding, right? So high parallel processing, right? Distributed computing, right? High speed computing is also possible using different types of artificial intelligence and machine learning models, right? So powerful models and algorithms are also possible, right? Using AI and machine learning, deep learning, right? Quantum computing. So recently a new area is being bloomed, right? That is quantum artificial intelligence, machine learning models, right? So leveraging all those technologies will help us to find the insights about the data, big data, right? So with this, we'll get into machine learning, right? So machine learning, as the name suggests, machine learning, so based on some training or experience, machine will learn how to react for a particular type of input or incident, right? So based on the experience, right, or the training, right, it will uh, generate the output. For example, machine can drive a car for you. So already in US, automatic taxis are implemented. Automated taxi systems are already implemented, right, in few uh, parts of the world, right? And machine can detect any kind of diseases, right? And it can unblock the phone, right? Like you are a biometric or face tracking, right? So which is already being implemented, right? So machine can do a lot for you, right? Once you train the model, right, it will do a lot of things for you, right? So traditional programming, uh, you have to uh, provide the data and you have to type the code, hard code, right, to generate the output. This is what you are doing in the traditional programming. Whereas in machine learning models, right, you have the data and you know the expected output. You have the expected output, right? So you will train the model in such a way that the machine will generate the program for you, right? So based on the data and the expected output which is given to the machine, it will generate the program for you, right? So when our new data is being uh, given to the machine, it will predict or it will classify the output, right? So then let us get into the different aspects of artificial intelligence, right? So artificial intelligence, so if you look at the diagram, see artificial intelligence is simply ocean. See, it's like a ocean. So, so under artificial intelligence, we have a different varieties or different aspects of artificial intelligence like machine learning, deep learning, right? CNN, artificial neural networks, right? So if you look at the right side, right? So data science is completely another domain. So where you have to have the knowledge of both computer science, statistics, mathematics, and the domain knowledge, research, development, machine learning. So you should have the knowledge of all these in order to become a data scientist. So data science is completely interdisciplinary field of study, right? So that requires expertise in various domains, various fields, whereas artificial intelligence is another thing. It's like a ocean. Under artificial intelligence, you have a machine learning, right? Deep learning. Now, now we are talking about quantum, multimodal AI, explainable AI, next gen AI. So there are lot of new technologies are being developed day by day, right? So, but the basics are never gonna change, right? So artificial intelligence is not a new term. It's been already implemented way back, right? But with the current development in the technologies, we are experiencing the outcome of artificial intelligence and machine learning now, right? So according to the definition given by Tom Mitchell, right, machine learning is actually a triplet, right? And it is a subset of artificial intelligence, right? So it's a triplet denoted as PTE, right? PTE. So here the P denotes the performance of machine learning models at some task. So you are training a model for a particular task. For example, you are taking a photo, right? So how to take, you are training a model on how to take a photograph at different angles, different light, different environment, right? So then you will check the performance of the machine learning when a new incident is coming for a new photograph is going to be being taken, right? So according to the definition by Tom Mitchell, it's a triplet performance at some task with the experience, right? Or the training, right? So machine learning model, ordinary, the difference between ordinary system and machine learning model is it it is used to learn from the experience, all right, and it will be useful to predict for the uh, future uh, prediction or future classification, right? Then based on the experience, it will improvise the result, right, or accuracy. So when do we use machine learning, right? Machine learning can be used whenever the human expertise doesn't exist. For example, when we launch satellite to the other planets like Moon or Mars, whatever it is, right? So uh, human expertise cannot be sent directly to the planets because we don't have the uh, survival capacities, right, over there. So wherever the human expertise cannot be cannot be provided or doesn't exist, we can make use of machine learning models. Then humans cannot explain their expertise, right? So it is not possible to annotate all the digital data that are being generated day by day, right? So approximately 2.4 quintillion bytes of data are being generated every day in your digital platforms like YouTube, Facebook, LinkedIn, etc. Right? So it is not possible for humans uh, to annotate or to process all these amounts of data uh, in order to get insight to the data, right? And you can customize the machine learning models according to your requirement or application, right? So these are all some things. Uh, why do we need machine learning, or when do we use machine learning, right? And at the same time, machine learning is not always useful at all the times, right? So for example, as I mentioned, there is no need to learn to calculate the payroll, right? So payroll uh, will be a fixed one for a particular period of time, at least for a year, right? At least for a year or so, the payroll is going to be remain to be the same, right? So machine learning is not useful to calculate the payroll because it's not going to change in the near future, right? So machine learning is not always useful, remember, right? So the phases in machine learning, so there are various phases. Like first you have to define your objective or research goal. So whenever you are going to implement a machine learning model or project, first you have to set an objective or research goal. Then you have to collect your data, right? Uh, there are various types of data, right? We'll discuss about the later part of the course. We have different kind of data like nominal data, ordinal data, right? Discrete data, continuous data, kind of things. So you have to collect the data required for your model, then prepare the data. So preparation means you have to pre-process it, cleaning everything. Then select the appropriate algorithm for your machine learning model. Then you have to train and test the model. Then you have to predict whether your model is working correctly or not. Then your model is successful, you can go for deployment. Otherwise you have to go back and select another model, train, test. So the iteration will keep on moving until it reaches the expected output. Say for example, here, see, we look at, we have a number of numerical digits, right? So you are going to train your model in such a way that what makes a numerical number 2. So you have to train with those images so that the machine has to detect whether the number is similar to numerical 2 or not, right? So, for example, see, there are various symbols that look similar to 2, but you have to train the model correctly so that it will detect whether the incoming number is 2 or not, right? So how does a machine learning model will work? See, as I said, first you have to set your objective, then you have to select the data, right? Then select the algorithm or model, then train and test the model. So first you have to split the data set into testing data and training data. So usually people will split 70-30, 70% for training and 30% for testing. So training data will be used to train the model, right? The training will not happen in a single step. Usually the training will be done multiple iterations, right? With the different kind of attributes, different kind of environmental settings, and so on, right? So training will be done first with the 70% of data, right? And then 30% of data will be used to test whether the model predicts the output correctly or not, right? So if it predicts the output correctly, then we can go for deployment. Otherwise you can go back to the model and you can select any other model or you can change the attribute, right? So that you can go back and predict whether it predicts the output or not, right? So this is how a machine learning model will work basically, right? So uh, it looks quite simple, but there are few challenges in machine learning model implementation that could be data related or methodological issues or resource related or any other miscellaneous challenges. We'll discuss uh, about these challenges in detail about the later part of the course, right? So these are a few applications of machine learning model, right? Web search, computational biology, finance, information extraction, social networking, debugging, and you can also add your favorite area. So in today's world, right, machine learning is applicable in all the areas, right? All the areas of in your life or day-to-day life, right? So coming to the machine learning types, right? So basically we have three types of machine learning models: supervised machine learning, unsupervised learning, and reinforcement learning, right? So supervised learning means you need a labeled data or annotated data, right? Unsupervised learning, we don't have such annotation or labeled data set. It will group similar items. Whereas reinforcement learning is a mix of both supervised and unsupervised learning. In other words, it will combine the features or benefits of both supervised and unsupervised learning. So apart from this, three, we have another machine learning model, right, called semi-supervised uh, learning. So part of the data will be annotated and part of the data will be raw data. So semi-supervised consists of uh, part of the labeled data and part of the unlabeled data, right? So machine learning, supervised machine learning. So supervised machine learning, when you train your model, the data set that is being given to the model will be labeled or annotated. See, for example, if you look at the diagram, see, this is the input that is being applied to the model, supervised machine learning model. So each image will be given with a label. See, for example, I have labeled it as duck or not a duck. So the machine will understand if it is a duck, these are all the features or characteristics of a duck, right? These are all the features or characteristics of a duck. If it is not matches with the features, then it will be categorized as not a duck. So with the label data set, you will train the machine learning model so that if a new data is being given to the model, it will predict successfully, right? So this is a predefined data set or annotated data set. So when you train your model, a predefined data set is being given to the model. It will predict. So based on this experience, when a new data is coming for prediction, the model will predict whether it is a duck or a not a duck, right? So this is how a supervised machine learning model will work, right? There are hundreds of supervised learning algorithms are available. Most popular are linear regression, random forest, support vector machine algorithms, right? See, here is an example. Decision tree is also one of the popular supervised learning algorithms. See, we have various conditions: temperature, humidity, windy conditions. So the idea is to predict based on these attributes. The machine learning model has to predict, is it possible to play golf or not, right? So you are going to construct a tree so that the machine will go through the hierarchical tree, right, based on the attributes defined in the data set, so that it will give you the final result. See, if the outlook is sunny, okay, you can go ahead. If the outlook is windy, if it is true, then don't play. If it is false, you can play, right? So the decision tree will be a hierarchical tree, so that you can move from the parent node to the child node or leaf node to predict the final output. So this is how the decision tree will work. Similarly, support vector machine. The idea of support vector machine is very simple. See, I have a group of people, male and female candidates, right? So I have a group of male and female candidates as per the height and weight, right? So I am going to draw a line, right? I am going to draw a line so that it will classify the two groups correctly, right? So if a new data point is coming for prediction, the line will help the machine learning model to predict whether the new incoming data is male or female. See, I am going to draw a line like this. It will classify the new data point as male, right? If I am going to draw a line like this, it will classify the new data point as female. So the placement of line should be good in such a way that it will classify all the data points correctly, right? So usually two or more planes will be considered. So the margin of closeness, right? Whenever a new data point is coming, the margin of close to the data hyperplane will be considered to classify the data point, right? So this is how the support vector machine will predict the output. So here is a question, simple question. We have two images, one is muffin, another one is cupcake, right? So muffin and cupcake are being given to the machine learning model. It has to classify whether the incoming data is for muffin or cupcake, right? So as you are aware that machines cannot understand alphabets or images, right? Machines can understand only the binary values, zeros and ones. So you can have a look at this data set, right? So these are all the top of the data set defines the characteristics of muffin. The bottom of the data set defines the characteristics or attributes of cupcake, right? So if you look at carefully at the attributes, that is columns, right? So there are few unique characteristics or attributes. For example, see, if you look at the first one, flour and sugar values, right? So amount of flour for muffin is more than 50 or 45, right? More than 45. Whereas for cupcake, the amount of flour is less than 45. So if the amount of flour is less than 45, then the machine can predict the incoming data point is cupcake. If it is more than 45, then it will be predicted as muffin. Similarly, the amount of sugar for muffin is less than 20. The amount of sugar value is less than 20, whereas for cupcake it is more than 20. So using these two attributes, right? These two attributes will uniquely classify whether the incoming data is muffin or cupcake, right? Muffin or cupcake. So this is how actually the machine will predict. So this is the code for predicting whether the incoming data is for muffin or cupcake. So based on the flour value and sugar attribute, a machine will predict whether the incoming data is for muffin or cupcake, right? So this is how you can write a program and to predict the new data point, right? So the next one is unsupervised machine learning model, right? Unsupervised machine learning model, as I said, we don't have a annotated data set or labeled data set. So the raw data set is being given to the machine learning model for training. So it will group similar items. So see, it will group similar items. So based on the shape or dimensions or attributes, characteristics, it will group similar items, right? It will group similar items. It will not predict anything, right? The primary objective of unsupervised algorithm is to group similar items, right? Similar items, and the grouping will not happen in a single step, right? It will take more number of iterations to finalize the grouping, right? Finalize the grouping. The same data set without any label, right? Without any label is being applied to the machine learning model, it will group similar items, right? So that it will be given some identification number, right? Identification number for each and every group. So there are number of unsupervised learning algorithms are available. So the most popular ones are k-means, right? Hierarchical clustering, a priori algorithm, right? So the main difference between supervised and unsupervised is, for supervised we are using labeled data, right? Labeled data, and direct feedback is also possible. It will predict the output, right? So based on the labeled data and the experience and feedback, it will predict the output for new data point. Whereas for unsupervised, it is non-labeled data, there is no feedback, and it is used to find the hidden structure in the data, right? It will group similar items, so it will be very much useful to find the hidden structure in the data, right? So most of the real-time data are unlabeled, right? Unlabeled. So it is not also possible to annotate or label the huge amount of big data, right? Huge amount of big data. So usually what people will do is the raw data will be given to the unsupervised machine learning model, so that it will group similar items. Then it will be applied to any of the supervised machine learning models to predict the output. This is what implemented in the real time actually. So clustering is one of the unsupervised machine learning models. It is used to find the similarity in the groups called clusters. So it will group similar items called clusters, right? So the similarity within the group should be small, whereas the similarity between two clusters should be more. So this is the basic idea of clustering, right? So clustering, we have k-means clustering, a priori, we have different types of k-meanoid clustering, right? So k-means is one of the popular and simple clustering algorithm. So simple, let us take a set of data points, right? Then you have to calculate the distance. You have to select a centroid or a head center, so that the distance from the center node to all other nodes should be minimal. So in such a way that you have to select a center cluster center called centroid, right? So it will create a cluster, right? It will form a cluster, and then it will select one center cluster center. The distance should be minimal from the center to all the nodes, right? So the cluster formation will not happen in a single step. It will move on. until it arrives at the best possible clusters, right? So this is what happened. So it will the recomputation of centroids will occur multiple times until it reaches the best possible clusters, right? Then various distance functions are available to calculate the distance from the centroid to the other nodes, right? I don't want to get into a deep about the distance function. We will skip it now, right? So based on the attributes again, right? Based on the attributes, it will group similar items. See, if you look at the attributes of banana, the length, the width, weight, right? So based on the attributes, it will group. So banana means it will be around 150 to 200. The width is around 35 to 40. Weight is around 170 to 30. Similarly, based on the attributes, it will group whether the data is banana or orange or mango or apple, whatever it is, right? So third category is reinforcement machine learning. So reinforcement machine learning, so it is based on the agent and environment. So it is based on reward based, right? So if the machine learning model predicts correctly, then the model will be rewarded, right? If the machine learning model predicts incorrectly, then the penalty will be given, right? And you can also have some policy, right, for the agent action, right? Agent action. So here the agent is nothing but the machine acts upon the incident or input on a particular environment, right? So environment is basically a situation in which agent is present, right? Whether it is a closed environment or open environment, what are all the surroundings, parameters, attributes, right? So action are the moves taken by the agent within the environment. So see, if you look at the diagram, you can easily understand. See, a machine learning model is being, this is the environment agent. So the input data is being given to the machine learning model, right? It will predict based on the training, right? And on the environment, it will predict whether it is an apple or not, right? If the prediction is correct, then the agent should be rewarded, right? If the prediction goes wrong, then the agent should be punished or penalty will be given, right? So this is the concept of reinforcement learning. So these are all the applications of reinforcement learning is used in robotics, gameplay, controlling, business, manufacturing, right? Industrial applications. So a difference, as we discussed, supervised machine learning, feedback, input, labeled input. Whereas in reinforcement learning, it is based on state and actions, reward based, no data set, no label data set. Find the actions that maximize the reward, right? The objective should be to maximize the reward, right? Maximize the reward, right? So it is very much useful to take decisions for a game or movie recommendation systems, right? So this is the quiz time. You can go through the scenarios. Scenario 1 is Facebook face recognition, right? Which algorithm can be used for Facebook face recognition, supervised or unsupervised or reinforcement learning? Can you guess? And you can tell me the answers in your comments. Scenario 2, Netflix movie recommendation. The third one is fraud detection, whether it is credit card or financial fraud detection. So there are various evaluation metrics, right? Out of those all, the most popular one is accuracy, precision, or recall. We will discuss about these evaluation metrics with an example in the next module, right? So this is the formulas used to calculate the accuracy, precision, right, recall, and specificity, right? So this is the confusion matrix. So So based on the predictions given by the machine learning model, the program can generate the confusion matrix, right? Based on which we can calculate all of these evaluation metrics, right? Evaluation metrics. So that's all. So we'll discuss about the next module in the next video, right? Thank you guys. Thank you for watching my video. If you have any questions, don't hesitate to ask me, right? Thank you.